Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's turn for the sp2 hybridization. For sp2 hybridization, let's take an example of boron trichloride. So that's boron trichloride BCl3. Before doing that, let's make the Lewis structure of BCl3. What's the atomic number of boron? It's 5. So the electronic configuration will be 2, 3. So the valence electrons of boron will be 3. That's 1, that's 2, that's 3. Now let's talk about the chlorine. The chlorine is having 7 electrons in its valence shell. That's 1, 2, 3, 4, 5, 6 and the 7. Chlorine 1, 2, 3, 4, 5, 6 and the 7, and here's chlorine 1, 2, 3, 4, 5, 6 and the 7. Here all the chlorine will make one covalent bond with boron. After forming covalent bond with the boron, the chlorine attains the 8 electron in its valence shell. Let's count it for the first chlorine. That's number 1, 2, 3, 4, 5, 6, 7 and the 8. So the first chlorine got 8 electrons completed after sharing 1 electron with boron. Now let's talk about the second chlorine. That's 1, 2, 3, 4, 5, 6, 7 and the 8. Here also chlorine completed its 8 electron in its valence shell after sharing 1 electron with boron. Now let's talk about the third chlorine. That's 1, 2, 3, 4, 5, 6, 7 and the 8. The third chlorine also completed its 8 electron in its outermost shell by sharing 1 electron with boron. But let's talk about the outer electrons for boron after it has formed 3 covalent bonds with chlorine. That's number 1, 2, 3, 4, 5 and the 6. Here boron is having 6 electrons in its outermost shell after forming 3 covalent bonds with 3 chlorines. So this was the limitation of the octet rule, where the central atom have not completed its 8 electron in its outermost shell. So today we are going to do its hybridization. In this case, maximum number of bonds are formed by boron as it's forming 3 bonds. So boron will be our central atom. So boron is our central atom. What's the configuration of the boron? Let's talk about the atomic number first. Atomic number of boron is 5. Then the valence shell electronic configuration of boron will be 2s2, 2p1. Now let's make its orbital diagram in the form of boxes. That's 2s, and 2p is having 3 degenerate orbitals. That's 2px, 2py, 2pz. Degenerate stands for orbitals with equal energy. So the energy of 2px, 2py, 2pz is equal. Now let's fill the electrons according to the configuration. The 2s is having 2 electrons. So that's first electron with a spin of +1/2. That's second electron with a spin of -1/2. And 2p is having 1 electron. So the first electron in 2px only. So First of all, this is called the ground state of the boron. Now, let's see the Lewis structure. Here, boron is forming 3 sigma bonds. Boron is forming 3 sigma bonds. And I have also told you earlier that 2 atomic orbitals having 1 electron each will overlap with each other to form the covalent bond. That means the orbital of boron having 1 electron will overlap with the orbital of chlorine also having 1 electron, and then they will overlap to form the covalent bond. Now let's see the box orbital diagram of the boron. Here the 2px is only having 1 electron in one atomic orbital, which will overlap with the atomic orbital of chlorine to form the 1 sigma bond. But we have to form the 3 sigma bond according to Lewis structure. That means in boron, there must be 3 electrons in 3 different atomic orbitals to form the 3 sigma bonds. For that, what's gonna happen? For that, 1 electron from 2s will excite to the 2p y orbital. So that will be the excited state of the boron. Let me make it for you. That's the 2s and that's the 2p. That's 2s, that's 2px, 2py, 2pz. So here 1 electron, the second electron and the third electron now in 2py, and that's our excited state. Now we got 3 electrons in boron in 3 different atomic orbitals. So now boron will be eligible to overlap with the 3 atomic orbitals of 3 chlorines to form the 3 sigma bonds. Now after that, hybridization will take place. The orbitals having electrons will intermix with each other in case of boron. That means 1s and 2p, 1s and 2p orbitals will intermix with each other. They will intermix with each other. What's that process called? That's called hybridization. So here total 3 orbitals are intermixing, the 1s and 2p, due to which we will get same number of new orbitals, that's 3 new hybrid orbitals. What will we get? 3 new hybrid orbitals which are having equal energies. So you can also say that 3 new hybrid degenerate orbitals, and that will be, we got the 3 new hybrid orbitals which are found by mixing 1s and 2p. That means the hybridization will be sp2. We got the sp2 hybrid orbitals which are 3 in number, in which per hybrid orbital we are having 33.33% s character plus 66.66% p character. Per hybrid orbital. So we got the 3 hybrid orbitals which are named as sp2 hybrid orbitals, in which we are having 33.33% s character and 66.66% p character per hybrid orbital. Now, how many electrons we were having? 3 electrons. So there will be redistribution of electrons according to the Hund's rule. That's the first electron in sp2, second electron in second sp2, and the third electron in third sp2. So we got the 3 new hybrid orbitals containing 1 electron each, which will overlap with the 2p orbitals of 3 chlorines to form the 3 sigma bonds. Now let's talk about the chlorine. Now we are talking about chlorine. Chlorine. What's the atomic number of chlorine? That's 17. So the configuration will be 3s2, 3p4. Let's make its orbital diagram in the form of box. We got the 3s and we got the 3p orbitals, which are named as 3px, 3py and a 3pz. So now let's fill the electrons. The 3s is having 2 electrons. The first electron with a spin of +1/2 and the second electron with a spin of -1/2, and 3p is having 4 electrons, so we have to fill that 4 electrons according to the Hund's rule. That means all the degenerate orbitals, that's 3p, x, y and z, will get 1 electron each first, then pairing will start. So that's the first electron, second electron, third electron and the fourth electron. There's one mistake, I'm so sorry. That's 3p5, sorry. So it will be 3p5, so that's our fifth electron. Let me fill it for you again. So we are having 5 electrons in 3p, so that's 1 electron, second electron, third electron, fourth electron and the fifth electron. So here we are having 1 electron in 3pz only, which will overlap with the sp2 orbital of the boron to form the sigma bond. So let's talk about chlorine over here. Let me talk about the first chlorine. That's a chlorine. Let's make its 3p orbital over here. We are having 5 electrons in 3p. 1, 2, 3, 4 and a 5. And that's our 3pz. So now what's gonna happen? This 3pz will have the head-on overlap with the sp2 orbital of the boron to form the sigma bond. So this sigma bond will be sigma sp2p, because this sigma bond has been formed by the overlapping of sp2 orbital of boron with the p orbital of chlorine. Now let's talk about the second chlorine. That's also the same chlorine. Now we are again having 5 electrons in chlorine. That's first, that's second, that's third, that's fourth and that's fifth. So we are having 1 electron in 3pz only, which will again overlap. This 3pz orbital of chlorine will overlap with the sp2 orbital of boron to form the sigma bond. So again, this is the sigma bond that has been formed by the overlapping of sp2 orbital of boron with the p orbital of chlorine. Now again, let's talk about the third chlorine. Let's make a 3p orbital diagram. Again, we are having 5 electrons in 3p, so that's first, second, third, fourth and a fifth. So again, this is the 3pz orbital. Now this 3pz orbital will have a head-on overlap with the sp2 hybrid orbital of boron to form the sigma bond. So again, this sigma bond will be sigma sp2 and the p, because it has been formed by the head-on overlap of the sp2 orbital of the boron with the p orbital of the chlorine. So here we got the hybridization to be sp2, because we got the 3 new hybrid orbitals, that's sp2 in the case of boron. Now let's talk about the structure of the boron trichloride. The structure of sp2 hybridization is trigonal planar. It's trigonal planar. That means boron is over here, first sigma bond with first chlorine, second sigma bond with second chlorine and the third sigma bond with third chlorine. Now here the bond angle will be 120 degrees. So that's the structure of boron trichloride. Now again, the one point about the energies. Here in first case, the energy consumed will be promotional energy. Energy consumed. The first energy is promotional energy, that is promotion of electron in case of boron from 2s to 2py. So the energy required for the excitation of electron from 2s to 2py is called the promotional energy, and that's an endothermic procedure. Second, for intermixing of hybridization, for the intermixing of atomic orbital, the energy consumed is hybridization energy. That's the hybridization energy which have been consumed. Now, when there is the formation of sigma bonds between the sp2 hybrid orbitals and the p orbital of chlorine, this whole process of formation of 3 sigma bond will be exothermic in nature. Exothermic in nature, obviously, which will release energy. So I am writing here energy is released during the formation of sigma bonds. During the formation of 3 sigma bonds, which compensates the two endothermic energies, that is promotional energy and hybridization energy. So when there is a formation of sigma bonds between the sp2 hybrid orbital of boron and the p orbital of chlorine, there will be a release of energy which compensates these two endothermic processes, that's the promotional energy and the hybridization energy. Only then the formation of BCl3 is possible or feasible. If energy is not compensated, that means if promotional energy and hybridization energy is not compensated, then the formation of BCl3 will also not possible. But here the promotional energy and hybridization energy is compensated during the formation of sigma bonds between the sp2 hybrid orbital of boron and the p orbital of chlorine. That's why this formation of BCl3 is practically possible. So that's all about sp2 hybridization. I hope you all understood it. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.